Hello everybody, my name is Carsten Wedler and I work in the project A6 of the CRC Transregio Oxy-Fuel. In this project we investigate how gas molecules diffuse in the pore structure of solid fuels and how the molecules attach on their surface. This process is called adsorption. When the molecules escape from the surface, we call this process desorption. Moreover, we investigate how this process is influenced by pore structure changes during the conversion of the solid fuels. When a gas is attached on the surface of the solid fuel, the mass of the solid seems to change. This can be measured with a highly sensitive laboratory balance. The problem is that we need to investigate this change of mass in a closed measuring cell. At this point, we use a technology which was developed at our institute at Ruhr University Bochum almost 40 years ago, the magnetic suspension balance. The weight of the sample is electromagnetically transmitted to a laboratory balance. You may say we weigh through walls. And since we are able to set the sample down and lift it up again, we can test the balance several times during the measuring process. This results in a very high accuracy. We use this technology in different setups. The first setup is designed for sorption processes at high temperatures. With this device, we are able to measure sorption equilibria at temperatures up to 1000 degrees C. The limiting factor is thereby not the temperature limitation of the apparatus, but the onset of chemical reactions. The second setup is designed to measure the dynamics of the sorption process and is equipped with a highly sensitive laboratory balance. The resolution of the balance was optimized and we can measure mass changes down to a millionth part of a gram. For the transfer to technical combustion processes, this information is extremely important because these are very fast processes. And we modify the third device in a way that allows for the measurements with condensing components as well. In terms of the Oxy-Fuel combustion process, we are mostly talking about water. By combining our sorption device with a gas chromatograph, we can measure the selectivity for the sorption process of gas mixtures. To investigate the pore structure in terms of internal surface area and pore volumes, we also use a volumetric sorption device. With this device, we can carry out standardized investigations of the pore structure without extensive effort. And since the aim of the CRC Oxy-Fuel is a detailed description of the combustion processes in Oxy-Fuel atmosphere, we have to describe our experimental results with a suitable mass transfer model. For this purpose, we have developed a new mass transfer model in Project A6. It enables a detailed description of the ongoing sorption processes and is a function of time, temperature, pressure and the pore structure of the solid fuel. This model is an important step forward compared to the very simplified models which are used in combustion models today.